One. So we are live. Hi, everyone. Thanks for attending this exciting webinar. We are here with Chaco Thomas from IBM and AJ Schifano from Oracle. Chaco, why don't you go ahead and introduce yourself?
Hey, good morning. Good afternoon, everyone. Thank you for joining us. We appreciate you taking your time and being with us today. Let me introduce myself. My name is Chaco Thomas, and I run the JD Edwards service line of business here at IBM. I've been a JD Edwards, almost a JD Edwards lifer, I can say that. And I also run our Oracle digital transformation practice, which essentially covers cloud, artificial intelligence, and a number of those areas around automation. So over to you, Ali.
And we've got AJ Schifano here from Oracle. AJ, please go ahead and introduce yourself.
Yeah, thanks, Ali. Hi, everybody. I am AJ Schifano. I'm a product manager in the JD Edwards product development organization with Oracle. I've been working on the JD Edwards product for 20 years. And in that time, I've seen a lot of things, a lot of water under the bridge. But I can honestly say in 2018, with all the technology that's surrounding us, there's never been a more fun, exciting time to be part of the JD Edwards organization, and really excited to tell part of our story here today with Ali.
Thanks, AJ. So before we go further, I'm going to give the agenda for the webinar. So what we're going to start is with the IBM Watson overview, which Chaco is going to take us through. Then we're going to talk about the latest and greatest on JD Edwards Orchestrator, which AJ is going to take us through. And then we're going to discuss a very exciting demo, which is going to tie up all the technologies, including Oracle IoT, IBM Watson, and JD Edwards Orchestrator in one demo. What we are going to see is a digital facility management for a production facility, and how IBM Watson machine learning is going to do a predictive maintenance using capital asset management modules within JD Edwards. The technologies we are going to be demonstrating are Oracle IoT Asset Monitoring Cloud, IBM Watson, and of course JD Edwards Orchestrator for an end-to-end demo. So I'll hand it over to Chaco to take us through what's the latest and greatest with regards to IBM Watson.
Thank you, Ali. So what I wanted to start off by is basically to give a little bit of a background in terms of our relationship with JD Edwards. AJ is here, on this platform today. Essentially, about a year and a half back, our teams got together in Denver, and we started to brainstorm around the concept of cognitive. And as many of you would know, IBM is a leader in the space of artificial intelligence and cognitive capabilities. What we wanted to really explore with Lyle and his team was how does this apply for JD Edwards specifically? And we came up with a number of use cases. We started to pull together some demos. And long story short, it's been about a year and a half in this journey. And we're very excited that we've got a number of different offerings now. There's a number of different offering plays of how JD Edwards and artificial intelligence, and I'm going to use the term AI, really comes together and works together. So a good part of what we're going to discuss today, you'll see a use case, an example of what Ali and his team has done. So the bottom line here is Watson is a big, broad brand. It's a big, broad application. It's a portfolio of services. But what is really critical is that how do you consume Watson? That's a question I often get. How is Watson consumed? So we're going to talk a little bit about that. But there are different types of applications you can build around Watson within the context of JD Edwards and Oracle. Some of them could be more complex and requires a different type of design, and others could be very, very fast and it's very easily leveraged by the average user. And you're going to see a great example today in today's webinar on a similar story. So with that, let's go to the next slide. What I really want to do is to start by actually defining cognitive. Oftentimes the word artificial intelligence, cognitive, artificial intelligence is the overall space, and cognitive is where we really pull in the analytic side of AI. And when you really think about cognitive, you got to think about pattern recognition. That is really the key, pattern recognition. If you can really understand what that is, and if some of you, who are fans of Ray Kurzweil, he's written a book called as How to Create a Mind, and it's a great book to really understand pattern recognition. So if you think about that, what we're trying to do is we're trying to bring that context of pattern recognition into our mainstream ERP world. And there are three ways that you can really apply this. The first one is in the area of cognitive analytics. So if you think about cognitive analytics, we live in a world of structured and unstructured data. There's data hitting us from all sides, all angles. How do you analyze that? What kind of a tool and mechanism can you use? What kind of patterns emerge? Let's take example of social media. Is there a pattern that emerges? If you are, say, for example, in the winery business, for JD Edwards customers, and there's lots of people taking pictures about the different types of cocktails and different parties that are happening around town. Can you look at that information and actually analyze the spend trends or the consumption trends of different brands of wines? And we absolutely have a solution around that. So that's absolutely possible. Cognitive analytics. So really looking at social media data, unstructured data, and structured together, and making predictive analytics around it. The second area is really cognitive IoT, and this has got a lot of different applications. If you think about the type of data we can access, from weather data to machine data, machines in your manufacturing facilities, automobile data, your Fitbit data, or even data coming out of your refrigerator. All of those kind of data, it's under the IoT umbrella. And you're going to see a great example when Ali and his team actually demonstrates that. You'll see cognitive IoT. And the third area is cognitive computing. And cognitive computing is, if you were to really put this in a layman's term, when you think about pattern recognition, what we're really trying to do is we're trying to bring mathematics to really do pattern recognition. So we are writing algorithms. But what if we could take those algorithms and really put it on top of high compute power, like what is available today in the cloud? So you start to open up the world to the possibilities of the data that comes in the cloud. When you do a simple Google search, you see a lot of that information coming because it's all in the cloud. But think of your enterprise application in that similar context, and you get into the world of big data, you get into the world of data lakes, and you're really using the horsepower of cognitive computing to amplify your experience of pattern recognition. And that really is the goal of cognitive computing. It's really to amplify the human cognition. What you can do as a human being, what if you could amplify that significantly using the power of cognitive computing, using the ability to integrate different types of data through IoT and cognitive analytics. Ali, next slide. So that's really where Watson comes into the picture. And to many people, Watson's kind of like a black box. You really don't understand how it works. But we're going to break down some of those pieces. Essentially, for those of you who've been following the evolution of Watson, Watson took on the Jeopardy champs in 2011. At that time, it was one big application, centrally hosted. And then we broke it down, and today it's in the world of the cloud. It's distributed. It is easily consumable, and you'll see how we can consume that. So it's able to give you information, answers. It's able to recognize patterns. It can actually communicate with us in the natural language. We can have real conversations. We can use language-based criteria when you're analyzing information related to the data patterns that emerge, so on and so forth. I mean, it can do a lot of different things. We just really need to understand what is the use case that we're trying to solve here, and what kind of a Watson attribute or function, or if I may use the word API, do I need to help me with this use case? So that's really what makes Watson different and how it can be used. It comes down to coming up with a use case and then determining what kind of API consumption you need. So let's go to the next slide. Ali, can you flip to the next slide? Thank you. So if you stay with me about thinking about what is a use case, so you might be in the distribution industry, or as I described, the winery industry, in the probably in the CPG marketplace, or you're probably in the medical industry. Irrespective of which industry you are in, you need to start thinking of this in terms of use case consumption. But then, what are the different things you can do with a solution that is cognitive enabled? Number one, you can actually engage with your users using an AI-based cognitive solution. So you can create chatbots. You can actually help your call centers, the number of the calls coming in, using speech to text and text to speech and tone analysis, in the call center, and really have a sense of engagement. So you can actually have a bot that engages with your users. And I'll give you an example very shortly in the JD Edwards context, but that's one area you can apply it. You can use it from a discovery perspective. And many of you who have been watching Watson, you've been hearing about all the pattern recognition, the genome discoveries that IBM Watson is really involved in. So you can use it to actually get into a discovery mode of something, a new product you want to launch, or a new service line. That's another area. You can actually use it to make decisions, where your cognitive system actually helps you in making those decisions through the predictive analysis, something you'll see today in a small way, what Ali is going to show you. But if you take the cancer treatment, you could have multiple options in a cancer treatment. But with the help of the detailed analysis and all the data that's available, the research that's available, you can actually make the right decision, or the most optimal decision, using a tool like Watson. You can also leverage it in policy management. So when you think about policy management, if you think about global companies that has to deal with constant changes in regulatory compliance around the world, how do you stay on top of that, and how do you automate that process of staying on top of these compliance issues? You can actually use an AI-based cognitive solution to pull that information together to stay on top of all these changes that happen in terms of regulatory compliance world. And of course, you can use it to explore, while you can get a lot of analytics coming to you, fed to you, but you can actually do your own exploration. And we are seeing good use of this in the oil and gas industry in terms of oil exploration, where we are leveraging Watson and the knowledge and the information that Watson provides in that industry. So these are like different types of examples of how you can use this tool. Let me talk in the next slide about how we actually consume Watson as an example. So this is how Watson is constructed today. And you will see there are different types of APIs. You've got conversation APIs, language translators, personality insights, tone analyzer, and so on and so forth. There are many APIs, and there's more APIs coming out. As I give you an example, how do you go and actually analyze a social media picture and thousands of social media pictures? You'll use the visual recognition API to do that. How do you actually have a dialogue? How do you create a chat bot that's interactive, that's got machine learning embedded in it? You'll go use the conversation API. Now, if you want to do a little bit more analysis of the context of that language, you'll start to use natural language classifier. If you are trying to analyze a text, or you're trying to analyze the tone of the person you're interacting with, you'll use a tone analyzer. So this is kind of how it's broken out. And another good example is Knowledge Studio. When you really get into machine learning and you want to build machine learning models on the back end, you'll use Knowledge Studio. Knowledge Studio really enables you to create these machine learning models, that you can, attach in the back end, and so the next time you don't have to recreate it. So these are different types of APIs, and this is how you consume it, depending on what you're trying to do. What does your use case really need? You start to get into that. And now, we've basically introduced a number of these solutions together with in the JD Edwards context, and you'll see a number of them mentioned there, from procurement intelligence to a direct-to-consumer solution, which is directly targeted at the winery industry, and so on and so forth. We also have a JD Edwards user assist chatbot that we have brought to market, where if it's a new user trying to actually interact with you and understand and learn about JD Edwards, you can actually, the chatbot will really, using an interactive chatbot, you can actually use that to replace your call center calls that are going in for level 1 and level 2 support. You can actually interact with a chatbot. But I have to mention that it's not just IBM alone. Oracle's also heavily invested and continue to invest, and you'll see the intelligent bots and adaptive intelligence and machine learning coming into all the portfolio of Oracle products. So it's not just IBM, but it's also Oracle. It's a combination of what IBM and Oracle can do together in this context, and that's what we're developing. Now you'll see an example very soon that Ali and his team have put together, where they've leveraged these concepts. And as I said, it's not just from an IBM context, but this could be used by any users. It could be used by our partners, and we're very proud to partner with Ali's company, Ephlux, and really go to market from an Oracle IoT perspective. With that, I just want to make a quick announcement. And what I tried to do was try to give you a picture of what is cognitive, how can you consume it, what are the different types of use cases available. It has been quite a high level, but just to kind of lay the foundation of what you're going to hear in the rest of the story, with the other two speakers. But we are doing a little bit more deep dive on this. If you're looking at a journey to the cloud and you're looking at what happens in the cloud, what does the world of cloud look like, including adaptive intelligence or artificial intelligence, robotic automation, microservices, all of those things. We are doing a webinar on February 14th, and I do want to invite you. We're doing it together with Oracle and JD Edwards. So with that, Ali, AJ, I'll actually hand it over to you as we get into the details of the Oracle IoT.
Great, thank you, Chaco. Awesome.
Right. AJ, feel free to share your screen so that you can take control of it.
Okay. Am I audible and can you see my screen?
Yes, you are audible. And let me just double check if you can see your screen already.
Yes, we can see your screen.
No, so I think we're seeing my screen still.
AJ, we're not able to see your screen.
Let me try again. Is that better?
Yes, now we can.
Yes.
Great. Yeah. Sorry about that. So yeah, Chaco, thanks for that overview of Watson and its significance with what's going on. Equally exciting story, I believe, from the JD Edwards standpoint, specifically on how JD Edwards is leading our customers into the world of digital transformation by keeping up with modern technologies. So to set the context, right, of digital transformation in a pretty exciting time, right? In my introduction, I mentioned that I've been with the JD Edwards team for 20 years. So certainly a lot of technologies and a lot of things have happened. But when we take a look at where we are in 2018 and imagine ourselves for the last 3 years and what's going to go on for the next 3 years, we're living in a pretty exciting time of digital transformation. We have new business models coming up. Uber and Lyft sort of revolutionizing the transportation industry, mortgages and electronic and self-driving cars. We have Internet of Things and ubiquitous connectivity, mobile applications and generations of users. operating and expecting their software to operate in ways that we had never imagined over the years. So to be in tune and to remain relevant in this digital transformation, we have to take a look at what's going on and do something about it. Now, the fact that your ERP system, like JD Edwards, over the years of collecting data, recording that data through a series of transactions, and then eventually reporting that data out, that's sort of a fundamental behavior that's not going to go away, right? You still need that diesel engine inside your enterprise, data, execute transactions, and report data back out. Yet, with all the technologies around us, from the Internet of Things, and as Chaco introduced us, the cognitive computing and big data, business intelligence, all of these things are now surrounding our ERP system to be able to interact with those to function in a digital economy. So certainly that digital transformation means transforming JD Edwards too. And I think if you're up to speed on the latest JD Edwards enhancements in the last just few years with mobile and Internet of Things, this feature I'm going to talk about in more detail called the Orchestrator, our user experience, our UX1 role-based user interface, personalizing and citizen developer, all these things, sort of, if you look at JD Edwards today, you may not recognize it compared to the JD Edwards of just a few years ago. But don't worry about that. We're still the good old JD Edwards like we always used to be. But on the outside, we are certainly adopting these to transform, not just in incremental enhancements to JD Edwards, but to help our customers transform how they use their very ERP system. And so in my view, it looks something like this, regardless of what you're doing. If you're manufacturing things or distributing things, maybe you're in the project industry and you're building buildings or homes, manufacturing medical devices, your business has a pulse. Coming in, inventory is leaving, you're manufacturing, you're doing work orders, you're doing financial transactions, and your business is happening at a pulse. And with every pulse of that business, enterprise things are happening. Eventually, that all ends up in the JD Edwards transaction tables. And those JD Edwards business data represents the lifeblood of your business. So the trick is, how do you take your core ERP system and make sure that it's in step, in line with the metabolism? Now, when we take that view, we also know, essentially all that ERP data is getting written to the database. We know we have a bunch of constituents, people who are using that JD Edwards system. Now, some of those are explicit traditional users. They sit at their desks, they enter transactions, financial transactions or work orders, or they're querying the system for data. That's been going on for decades, and we know how to do that very well. In the context of digital transformation, we need to recognize all of the users of that system that may be less traditional, that want dashboards, they want to see things, and they don't want any concept of that they're using an ERP system. They just need charts and graphs that are accurate and real time and easy to access. Mobile and kiosk users, right? Maybe users on a manufacturing shop floor that need very efficient, simplified, whittled down user interfaces. Now, they're still using the JD Edwards transactions, but maybe it's only one or two buttons in one field to complete. So if they need that, we know that IoT devices, non-human users, are now able to collect data, status, and transmit data to the JD Edwards system. And it's not even a living, breathing human being, but it's a device that's actually a user system. And of course, as Chaco teed up, there are a lot of third-party and cloud systems out there, whether they're cloud applications that customers are growing to adopt, or things like IBM Watson, both as a user of the JD Edwards system and also a consumer of data coming out of JD Edwards. So we need to figure out a way to expose all the traditional JD Edwards data and applications out to the users, the participants in this digital economy. And so how do we do that? Well, one way, and probably the most significant way, is this product that we've delivered called the JD Edwards Enterprise One Orchestrator. We've got that traditional way of end users using JD Edwards applications. There are hundreds of these applications, and we've been developing them and refining them and enhancing them for literally decades. And we've got thousands of JD Edwards business functions, and our customers write their own custom business functions their way. A very powerful feature of the JD Edwards applications for both to accept the functionality that we put out in the form of our applications and business functions, but also customers who have honed their system to do it their way. And so all that leads into filling up the business data. Typically, our customers will have hundreds of gigabytes, maybe even terabytes of business data. And again, that's the gold, that's digital gold to them. But how do we get that out to the digital economy now? And so there's this function, a new service we call the Application Interface Services server. And within that server, this product called the Orchestrator, at the application level, expose JD Edwards functionality via REST services, both inbound and outbound, out to the digital economy. And that integration at the applications level, including this feature we call the Orchestrator Studio, allows business analysts in a very non-technical way to create these things called orchestrations that automate JD Edwards business processes simply by automating how the applications are invoked and used. So what I like to say is, if the business analyst is smart enough to use the JD Edwards applications, they're smart enough to build these orchestrations using the studio and automate business processes. Well, this is the very technology that we've used to build mobile applications in a sort of an expedient and efficient manner by not recreating all of the application logic that already exists in JD Edwards, but only requiring the mobile applications to collect data, send it to the JD Edwards Application Interface Services server, and report data back out. And we've built our mobile applications using this technology, and customers can build their own. This is also the foundation of our Internet of Things solution. Let's say it's a forklift, merely needs to ping the AIS server through an orchestration to report, for example, its status. Is it working? Is it down? Is it available? Its engine temperature, its latitude and longitude. Any of that data can be collected and sent through orchestrations and end up in the JD Edwards applications. This is also the foundation for all of our UX1 components. We're collecting a lot of data, business data itself, in the tables, and we're using this mechanism to then fill up charts and graphs and watch lists in our user experience paradigm we call UX1. This is a prime example of a way to automate processes. So for example, if you want to string 3 or 4 or 5 actions together, I want to register a new piece of equipment, I want to collect its initial meter readings, and I want it to declare its latitude, longitude, and status. Those are like 4 or 5 transactions that could be easily accomplished in JD Edwards forms by an end user, but it's also a process that could be automated into a single orchestration, and that forklift can do all that simply by pinging with a little bit of data. And of course, in the context of this very webcast, right, think about extending the JD Edwards functionality out to cloud services or something as powerful as Watson, right? Can we, in the midst of a transaction, can we go out to Watson and ask it a question and give us an answer back that's critical to us making a decision in the transaction? Or conversely, all into JD Edwards and get some answers, like Watson would be able to detect from the JD Edwards how many forklifts are in a status of available in warehouse number 2217, right? That's the kind of answer that we can query out of the JD Edwards system using the orchestrator. And of course, partners are at liberty to build their own applications using the same application interface technique to get into the JD Edwards application logic and business data system in ways they've never thought of before. So on the right-hand side, your JD Edwards applications, especially the customizations that you've made, and your business data, gold. But that gold is nothing more than a pile of metal unless you can take that digital code and exchange it in the digital economy. Excited about this application interface services server and the orchestrator and the ability for it, JD Edwards, participate in the digital economy. So it looks sort of like this. I mean, I said if you're smart enough to use the JD Edwards applications, you're smart enough to build these orchestrations that you build will have typical sort of verb type names, right? I want to onboard an employee. I want a low inventory alert. I want to know if the equipment status is down. Things, they become services. Now there's a term out there called microservices, and we can do some semantics and debate. The cloud world sort of calls microservices in a different context of the ability to spin up a virtual machine or maybe a virtual container, a Docker container, do some piece of work and shut it down. That's not what we're talking about here in that context. About the ability, the very powerful ability to write these services into the JD Edwards applications and have them do what you want them to do. And again, we've done this in a way that we hope enables the business analyst, programmer, not a JD Edwards developer, but a business analyst who knows what's going on in the business, these services and deploy them. Now, another offshoot of that is a relatively new feature we put out called notifications. So based on this concept of orchestrations, right, we can, JD Edwards system, we can recognize a condition out in the world via an outbound REST call, whether it's the price of plastic in Bolivia or the weather in London, whatever it is, inbound and outbound. We can read our own JD Edwards data. Is our inventory low? Is there a shipment coming in? Are there work orders that are overdue? Any condition of the enterprise can be detected, and then by this notification system, subscribe to events and get notified on wherever and whatever device they want. It could be through email, it could be an SMS message on their phone, user interface on the JD Edwards screens themselves, alerts. So no matter what's happening in the business, wherever they are, if they're on the shop floor or behind a desk or even out in the field, they can get notified in real time with links to go back to the JD Edwards applications and take the appropriate action. Again, a great way to extend the JD Edwards functionality. We're on the move. So that brings us back to, where we are now is Enterprise One, what I want to call ERP with a pulse. As things are happening in your business, and are automating and running on a scheduler and detecting conditions or events, automating data input or alerting people to specific conditions. And when we think about integrating that out to systems as powerful as Watson, I think customers are going to learn to use their ERP in ways that they just haven't used it in the decades past, and that makes it an exciting time. So, I'll wrap up by saying this JD Edwards Orchestrator, it's not just for Internet of Things. It is an interface between IoT devices. It still does that as a great job, but it's inbound and outbound REST integration. It's a guardian over your data to automate and take error out of human-based data input for accuracy and consistency. We can build bots for these. You can imagine writing chat bots to get data out of the JD Edwards system and integrating to the other external web applications. It's a notification engine to tell users what's going on in the system. And we think that customers and partners are going to find immensely creative ways to use this orchestrator and just get more value out of the JD Edwards applications and business data they own. So that's why we're so excited about it. Now, Ali is going to show you one specific case of how the orchestrator to integrate real-time data and events coming in and invoke sort of a specific set of JD Edwards applications. As he goes through his demo, I'm going to challenge you to use your imagination on other ways you could do the similar concepts. I will turn it over to you.
Yeah, thanks a lot, AJ, and thanks, Chaco, for such a deep insights that you've shared both from the IBM perspective and also from the JD Edwards or Oracle's perspective as well. So what I'm going to try and do is within the context of all these wonderful technologies that are now available, uh, break it up into a storyline of a production facility. So let me highlight my screen here. So we're going to take a case where there's a production facility and using the power of Oracle IoT Asset Monitoring, IBM Watson, and JD Edwards Orchestrator. How all of that can be tied together to be able to monitor your facility as well as do the capital asset management of your facility. So before we get there, just a little bit about uh, where we are in terms of this, automation. So obviously, there could be a manual and reactive work order that you could create if you talk about the maintenance. Capital asset management or shop floor management, they obviously give you a much more structured way of being able to have a periodic maintenance schedule or your production floor schedules that can be leveraged to obviously enhance efficiency. Now, when we talk about IoT, it obviously gives you automation. It automates that process by not having to data enter values that are coming in from those equipments so that you can automate that process. But using technologies like IBM Watson and cognitive platforms, what you can actually do is create the predictability aspect. Or you can actually predict what can go wrong in the next maybe few weeks and do something about it in a much more proactive way. So that in mind, what the storyline is. So let's think about a production facility here, which has hundreds of equipments doing their job, creating working on the manufacturing work orders and doing some wonderful stuff. Now, within each equipment, there is a PLC or there's a set of sensors that are interfaced with this equipment, which gives you tons of data insights that come out of these equipments. They give you the data that you could use to actually not just monitor it, but also predict what could go wrong with this particular equipment. So the storyline is that we are going to capture the sensor data from this production facility. And we're going to see a live demo for this. We're going to pass that data stream onwards onto IBM Watson using the streaming analytics service, which is going to not just ingest this data right from Oracle IoT Cloud Service, but also filter that and then analyze it. Now, based on that, what we are going to further see is a machine learning model that we've created, which is on one side is going to learn from that data through those patterns, is going to learn and then also predict. And then we'll see the closed loop that we've created from JD Edwards backwards into the IBM Watson to have a supervised learning that can further mature that machine learning model that we've created. And then obviously once you predict, then you can trigger an orchestration inside of JD Edwards. We're going to take a quick look of one orchestration and how that's going to automate creating this service work order and doing the invoicing or job costing around that as well. So that in mind, let us quickly jump on to more of a flow of how this is working. So within this production facility, the data is being captured inside of Oracle IoT Cloud. From there, it's being sent out to this sort of a middleware that we've created by integrating the streaming analytics of IBM Watson and JD Edwards Orchestrator together. So we're going to follow this architecture, and let me try to break it up, and we'll be deep diving into each one of them as we follow the demo. So there's this physical production facility, right, where we've deployed some real sensors. Right now, just to oversimplify that, we are noting the temperature, we have a thermal sensor, we have a humidity sensor, we have a motion detector, right? Then we have a sensor interface, which is getting all that data, passing it onto a fog unit, like onto a local gateway. There could be one or more fog units within the production facility, and then sending this data out into the Oracle IoT Cloud. Now, on top of the Oracle IoT Cloud is the Oracle IoT Asset Monitoring app, which is that SaaS application. What we've done is we've leveraged that to build a digital production facility management solution that you're going to see in a quick bit. So what we're doing is we are leveraging the JD Edwards adapter, we're leveraging the IBM Stream adapter or we've actually built the stream adapter to be able to ingest the data from Oracle IoT and pass it on to the IBM Watson. Now, once that data is passed on to the streaming analytics service of IBM Watson, we are ingesting it, we are filtering it, we're analyzing that data, and then passing that data on to the machine learning model to be able to train that model so that it can learn through that stream of data that is coming in. Now, once it has learned enough where we can start to rely on its judgment, we can let it predict a potential failure. And not just predict, but also trigger a request in the orchestrator, which in turn is going to create all that is need to be required to be done within JDE Edwards module. So that's the storyline, right, which we are going to follow here. And then what we created is a digital facility management dashboard, which can pull the data from all these different areas to give you a complete end-to-end picture of the scenario. So the step one is the digital facility management using Oracle IoT Asset Monitoring Cloud, right? So we are talking about this particular portion. So what we've done, this is a high-level bird's eye view of the architecture, where the production facility, all these three sensors are being interfaced in the gateway, passed onto the Oracle IoT Cloud, and then there's a custom application, like we said, for the facility management that we've built, which is passing the data onto the Oracle IoT application. So within the same context, what we've done, this is a production facility here that we've created. And in the interest of time, let me just actually show you the real environment here too, of how this actually looks within the system. So here, I'm going to search the geofence of this production facility. And by the way, these are real sensors, which we've deployed in our lab. But the only thing we've faked is that we've just changed the GIS location to make it look as if it's somewhere in the Midwest in an actual production facility. So if I click on one of these devices, the sensor data that is being collected for temperature, for humidity, all of that is being reported or being monitored by the Oracle IoT Asset Monitoring, right? The next step, going back to the presentation, next step, what we've done after looking at this data, we've created, as I said, the dashboard, which can report it on a more end-to-end or comprehensive across the application basis. Now, the second step is where the Oracle IoT data is being ingested inside of IBM Watson. So let's take a look at that, of how that portion looks like. And just to give you the context, this is the portion we are going to now see as to how this data is being pulled in and being used to train that machine learning model. So let me go back to my browser. Now, this is that IBM Watson streaming analytics service. So what I'm going to launch here is a streaming analytics console. What that console is going to do, let me shut that off. So what I'm loading is the Streams console. The Streams console is connected to the Oracle IoT Asset Monitoring data stream. So all that sensor data that you actually saw here, which is all in the real time, is getting ingested inside of the IBM stream. So you'll see these data tuples coming in, which is actually being collected from the real data stream from Oracle IoT Asset Monitoring. Just to validate that further, let me actually open up that data stream log, which is being captured. And we'll see how the machine learning model is going to use that to train itself. So these are the messages, like as I said, that we're using one of our labs where the sensors are deployed, and this data is being captured in the real time, right? So the humidity data, the motion data, and the temperature data, all of that is being ingested inside of IBM Watson through their streaming analytics service. And then it's being passed on to the machine learning model. So what we've done is we've created a basic streaming analytics model whereby we've used a basic classification for that. Let me just go back to the slide real quick, just to give you the context. So we were looking at the stream console here, and you're looking at the log viewer. Now, the third step is that we've actually created a machine learning model, and we've defined that how this machine learning model is going to consume that data and what it's going to do with that data. So here, for simplicity's sake, we've just taken a binary classification. In the real world, there's going to be hundreds of different data points being collected from different sensors. It's going to be doing a more robust sort of analysis, if you will. But for simplicity's sake, to clarify the concept, we've taken the binary classification. And what it's going to do is it's going to tell us that what is the probability of this equipment part failing, right? So we've defined a simple class which says that the probability is that is 100% of it failing, right? So let me show you this portion again in the real environment. So going back to this model, right? So this is the data model which we trained based on that IoT data coming right off the production facility, and then we can predict that. So right now I'm showing it through the user interface. That same, we programmed it in Python to be able to do that automatically as well. But it's hard to show you the backend code. So I'm just showing you how the prediction actually works and how that data prediction happens. So in the real world, obviously, there's going to be multiple parts, multiple equipments, or multiple spare parts that might be showing probability of failing. So let's assume a scenario where you get that in the next 2 weeks, there's a 60% chance of this particular equipment failing, right? Now, what you are going to do, and this is where it really gets very exciting. How do you use that data, that probabilistic model, to then invoke an orchestration inside of your JD Edwards, which is aware of the capital asset management module and how you configured that. So now this is that portion we are moving towards, and it's going to get really interesting. So just for the JD Edwards audience, you all know that how the capital asset management module works. You have an equipment master, you have spare parts, you have the labor that might have to be required to fix a particular issue with an asset. So you have all of these things for the maintenance work order. You have to end up doing that all manually in a non-digital world, where maybe somebody reported some funny noises coming in from the equipment. So you send a technician, the technician finds out and does some initial diagnosis, and then you create your work order and send out the actual technician to fix that. Now with this solution, this end-to-end integration, what's going to happen is this whole cycle is getting automated. From the point where you saw the IoT asset being monitored within that geofence, this sensor data being analyzed inside of IBM Watson, and using the machine learning model that we saw, we are predicting what's going to happen. And then it's going to invoke the actual orchestration. So now here, what we've done is we are using a sample orchestration here to create an alert and emergency work order. So now let's assume there's 90% probability that this equipment or this spare part is going to fail based on hundreds of different sensor data points that you collected, and your machine learning model is mature enough to give you that insight, right? So what you're going to do based on your policies within your JD Edwards that you defined, then what exactly should you do? Like, is 60% probability a big red flag, or you would like to wait till 90%? It could also take into account if you have a scheduled maintenance cycle of 1 month, and it's just 3 days, after which you have to go and do the scheduled maintenance anyways, and the probability says that this thing's going to fail in 7 days, you would rather not create an emergency work order. But if it's not, you could actually create that. So you can very well realize the value of how you're utilizing your core JD Edwards hardcore business data and marrying it together with the predictive analytics of the Watson, which in turn is pulling the data out from IoT sensors to actually create not just the alert or the work and the work order as well. Which what it does is it actually goes inside of your JD Edwards, automatically creates that, utilizing that application interface service framework, where you don't even have to come in and do anything manually. So everything happens magically for you. So that's the end-to-end demo that we wanted to show you. The art of possibilities are limitless. The possibilities definitely are limitless here, right? So as AJ said, while you're looking at it, you could think of so many different use cases that this could be useful for, not just for production facility monitoring, but also for actual production batch monitoring, and so on and so forth. So that kind of brings us to the Q&A. If you have any questions, feel free to put them forward, and I'll put them in front of the audience here. Okay, so one question we are getting here is, AJ, you mentioned about the orchestrator is not really an IoT orchestrator only at this point. Could you explain us how you came from, what were the logic behind IoT orchestrator versus the JD Edwards orchestrator?
Well, yeah, sure, Ali. The when we launched the product that we went out to market with, we built IoT into its name to emphasize the fact that JD Edwards applications can now be extended out to non-human users. So, and there was a lot of buzz about the Internet of Things and having devices attached to equipment or manufacturing lines, whether it's forklifts or vehicles or equipment. And certainly, if you look at the JD Edwards application modules, we do a great job of managing equipment and work orders and service orders. And many of our customers have assets like forklifts or conveyor belts or trucks that are on the field. So we're trying to capitalize on the fact that the JD Edwards applications can now be extended out to non-human users. As we started talking to customers about that, though, feeling sort of alienated. It's like, well, this orchestrator thing is interesting, but I'm not doing Internet of Things, right? And we thought what our customers were sort of missing out on a lot of the value orchestrator can provide simply by automating other JD Edwards processes, even if that process was not initiated by a ping from an IoT device. So in taking IoT out of the name, we haven't done anything to invalidate all of the IoT use cases. Those are certainly valid as they ever were, but we're hoping that customers will now understand that the orchestrator is a broader way to get data out of the JD Edwards system, get data out of third-party systems, make some primary preliminary analysis, and eventually, as JD Edwards is designed to do, to be the system of action, to invoke some action in the JD Edwards system. So the orchestrator, by taking the IoT out of the name, we hope that customers will understand it's got much broader uses connecting IoT devices.
Yeah, thanks, AJ, for that. The next question we have is for Chaco. So Chaco, the question is that from the context of the IBM customers who have JD Edwards and they have hosted on IBM Cloud, what is your message to them? How do they go about? What are the steps to success to adopt technologies like these? Chaco, we cannot hear you. I think you're muted.
Okay, I'm sorry. Can you hear me now?
Yes.
All right. Sorry. Okay, so what I was saying is for customers who are on IBM Cloud, most of the topology of the architecture that you described, will hold true, because it does not matter when you're reaching out to IBM Watson. You're reaching out to the Watson Developer Cloud, which is essentially an extension of IBM's Bluemix platform. So it depends on which cloud you're on. IBM's got different cloud variations there. If you're on the Bluemix cloud, it's the Watson Developer Cloud is an extension of that. If you're not on the Bluemix cloud, it's you're going to be accessing the Watson Developer Cloud using the REST API protocol, just like it was described.
Okay, thanks a lot, Chaco. So the next question is actually for me. So people are trying to understand what is Ephlux doing with IBM and Oracle, and what is the, what is are we trying to do together? So I think Chaco basically mentioned that briefly, that we are partnering up together to have some sort of joint offerings like these, where we have a strong expertise when it comes to Internet of Things. We are on the customer advisory board for Oracle when it comes to IoT. We are working on some very interesting projects. Now, obviously, having the expertise, or building our expertise on IBM Watson, the idea behind that was we can somehow be that bridge between IBM and Oracle. So the product roadmaps for each companies, they obviously are there, and they're going to be keep working on that. But in regards to GBS, which basically Chaco represents, the Global Business Services from IBM, our role that we feel, and Chaco can correct that further, is to be able to bring this expertise together with IBM and build these sort of go-to-market solutions together that can be leveraged by both IBM customers as well as Oracle customers. Chaco, would you have a quick word on that, please?
Yes, Ali, let me just add to that. So Eflux is a great SI in the IoT space. I've been working with AJ before we were talking about Watson and all these cool things that have developed. So this is a great partnership community, and the way this will progress is, if you're interested in working through these IoT, you can reach out to Eflux, and we will work and collaborate. And you'll hear a number of different initiatives that we probably will announce or do a similar joint webinars around other use cases. But our goal really is to bring this to the broader JD Edwards community, so that you can consume it, irrespective of whether it comes from IBM or it comes from Eflux. Our goal is really to expand the JD Edwards experience through cognitive and IoT coming together.
Okay, thanks for that, Chaco. Do you have any final words, AJ, on the webinar overall, or on the relationship that Eflux has with JD Edwards?
Well, yeah, I'd just like to say that we really appreciate the strong ecosystem that surrounds JD Edwards, represented here by Chaco and IBM and Ali and Eflux. Yeah, I mentioned that I've been working with JD Edwards for 20 years. So as we all know, JD Edwards is a system that was not born yesterday, right? But we do believe strongly that it is a system that's well positioned for business of today. So we hope that with this backdrop of the context of digital transformation and Watson and Internet of Things and the JD Edwards Orchestrator, we hope we at least spark your imagination to think of ways to use your ERP system in a way that probably is different than you have been in years past. That we will be your partner, your trusted partner on your path to digital transformation.
Thank you so much, AJ. Thanks a lot, Chaco, for taking time out for this webinar. I really appreciate that, and I'm sure the audience here really appreciated the insights that you shared. And that brings us to the end of the webinar. Thank you so much, guys, and have a great day. And everyone out there, take good care. Bye-bye.
Thank you. Have a good one.